Okay, here we are in 11.1, and now we're going to solve another proportion. But this one is one that is going to have a solution that is not going to make the equation true. This is going to be an extraneous solution. So here we go. Y squared minus y, 9, over y plus 3 is equal to y minus 3 over 2. And we're asked to solve this proportion. We'll start off and we'll cross multiply. When we cross multiply, we get 2 times y squared minus 9, and then we get y minus 3 times y plus 3. So we're going to have to use the distributive property on the left and the distributive property on the right. When we do that, on the left we get 2y squared minus 18. On the right we get y squared minus 9. Yeah, I know you recognize that's a difference of squares. At this point, you're supposed to recognize, wow, this is a quadratic. And since it's a quadratic, we're going to now get, we're going to put it in standard form, that is, get a 0 on one side and everything else on the other. Well, not quite. We're going to get the y squared to the left side and the 18 negative to the right side. And when we do that, we get y squared equals 9. Now we'll take the square root of both sides, and when we do that, we get plus or minus 3. Now, most students, this is where they make their mistake, because anytime we have a rational equation, we have the possibility of an extraneous solution. An extraneous solution is one in which our answer makes the equation false and not true. And the easiest way to see this is by looking at the denominator that has a variable in it. So up here we have a y plus 3, and when we look at that, we can ask ourselves the question, what number could be put in for y that would make the equation not true? And it's going to be a number that's going to make the denominator go to 0. Guys, we don't know how to divide by 0 yet. And so this negative 3, when plugged in for the y, will make the denominator go to 0. And therefore, negative 3 is what we call an extraneous solution. It's an answer that makes the equation false. Now, that's the easiest way to check for an extraneous solution. There is another. The other way to check for the extraneous solution is to plug it back into the whole equation and see if it makes the equation true. So if we plug the positive 3 in, by the way, this is not a method that I use very often. I use the other method where I'm just going to plug it in and see where the denominator goes. So if I plug in a 3 and I simplify it all out, we get 0 on the left and 0 on the right, and that makes the equation true, so 3 must be a solution. If I plug the negative 3 in, I'm going to get a 0 on the left and a negative 3 on the right. And so the negative 3 is an extraneous solution. So either way, you can use either one of those to check for extraneous solutions.